Hello, we'll be diving into my video assignment of conservation of energy for bungee jumping. So first off, we can look from this GIF that there's a person jumping off of a high-story building, jumping off with a spring connected at the end of the rope with initial H1 being 2 meters and H2 maximum stretch of 5 meters. The problem statement that we'll be working on is the spring attached to the person has a spring constant K of 200 Newton meters and its unstretched length is 2 meters. When the person jumps, the weight of the potential energy then stretches the spring by 3 additional meters, totaling for a stretch length of 5 meters, before coming to a momentary stop at the lowest point of the dive. The person mass is 7 kilograms. What we'll be finding is the maximum velocity Vmax reached before the spring stretches to its maximum length. Before diving into this problem, let's go over the givens and assumes. So some of the givens are the units and variables like mass, spring constant, unstretched total stretch of the spring length. Something that we also want to implement is negating air resistance and acting as if the person's a particle and assuming that all motion is vertical and gravity is 9.81 meters per second squared. Some of the formulas that we'll be using is gravitational potential energy conservation, spring equation, and kinetic equation. So first, to find the height, we'll take the height final and initial, which gives us 3 meters, and then we can solve for V1 and our conservation of energy equation to get the mass with 70 kilograms, the gravity 9.81 meters per second squared, and the height being 3 meters. And initially T1 is 0 as there's no initial velocity before the string was stretched. And then now we can solve for V2 and T2, where our spring and kinetic energy equation comes into play, where we plug in 1/2 200 Newton meters times 3 meters squared and 1/2 mv squared. To lay out all the equations that we've written out, we get that from T1 plus V1 equals T2 plus V2, we get mgh equals 1/2 kx squared plus 1/2 mv squared. So now we have left to solve for Vmax. By moving around the equation and doing algebra, we get that the Vmax is roughly 5.74 meters squared. Thank you.